just record. Okay, so I should just holler at everyone. You got it. All right.
I mean, this is a small
All right, so hopefully all of this works. Great. Okay, so it's 7:13. Good. Okay, hi. Good evening, everyone. So I want to talk to you tonight about data and data privacy and just, this sea of data that we're supposedly being filled with. I'm Marco Carmosino. I'm a PhD candidate at UCSD. We'll be talking about understanding and mitigating privacy threats as distinct from security threats. And this talk is very much in the everything else bucket of the Ruby on Rails talks. So let's get started. So we're supposed to have big data now, right? And if you Google big data, looking for images to put on slides that say big data on them, you generally get these like blue shiny things with lots of like Matrix-esque special effects. It's really not clear what these mean or why this is what we imagine when we think big data. But realistically, when we talk about big data and the promise of having access to data sets of unprecedented size, there's certain technological promises that we think of. We think of like actual self-driving cars or autonomous machinery. We think of personalized medicine. We think of going in and doing a better job with drug trials, genetics, predicting health outcomes, all of that kind of thing. And we think of using rich sensor networks embedded in the power infrastructure to carefully manage like windmills, different types of power, different types of emissions, and more efficiently deal with our changing climate and the changing energy demands. So the promises of what can we do now that we are flooding our computer systems with an unprecedented amount of sensor data and data about me and you, they're pretty good. Like, this stuff sounds decent. But also, there's like maybe some bad stuff on the way. Like, the computers are going to get too smart and kill us all. But no, that's not what I'm here to talk about tonight, although maybe that's a real problem that other people will talk about someday. No. Today, what we're going to talk about is, first I'm going to tell you what I'm not going to talk about, the risks of big data. I'm not going to talk about security. And this is a thing that is in the news a bunch. For instance, Yahoo in 2013 just lost 3 billion of their accounts onto the internet. They leaked usernames, passwords, some demographic information with different accounts, and then that can be reused across sites to compromise your banking information, steal stuff from you, etc. Capital One, apparently last week, lost access to like 106 million of your credit card records. That's also not good. People should not have this information about you. And also in the news recently, Equifax, a company that is apparently designed to hold on to as much personal information as possible and make risk judgments about us, didn't patch a flaw in some Java framework on their servers that was like 2 months old, and then leaked 143 million accounts full of sensitive information like social security numbers, etc. This is not what we're going to talk about tonight. These are security threats. They are inherent in collecting a huge amount of data about all of us, right? Because now there's these companies that have millions and millions of records of your personal information. But when everything is operating correctly, they don't let random hackers into their systems. So we're not going to talk about security problems. That's the domain of cryptography and maybe patching your Java servlets, which Equifax perhaps should have done. No, we're going to talk about something else, which is much more nebulous to define. We're going to talk about privacy problems. So for instance, Facebook knows a whole bunch about you, and that like maybe leaked to Russian hackers that helped manipulate our election. ComScore knows an enormous amount about you. They follow your habits across every website possible with tracking cookies, and they link you across different online stores. Target does this thing where they estimate if someone is having a baby, is pregnant, through their purchasing habits, and then send you advertisements for baby stuff when they figure this out. There's a really fun news story circa 2012 where a girl's father in like North Carolina or something showed up at a Target super mad because they were like, you're sending my daughter all this pregnancy stuff. She's like 17, she's not pregnant. And the Target owners, apologized up and down, and then he went home and he was like, look at this, can you believe this? And then there was a tearful conversation. She was like, no, actually, I kind of am. Like, Target figured this out before people around her. That's not a great outcome. LexisNexis Risk Solutions is a company that is a so-called data broker. It has huge files on probably all of us that it's a fun exercise to request what they have on you, because you can. There's some nominal fee associated with it. And what they do is other companies come to them and ask them queries about us and our behavior. And one of those companies is starting to be health insurance. So tenuous linkages between marketing information and behavioral information can start to impact the price of your health insurance, credit decisions at your bank, employment offers perhaps, as more and more of the data that is collected about you is centralized, subject to statistical inference procedures that you and I know nothing about, and then used to make important decisions about our lives. That is the kind of threat that we are going to discuss tonight. We want the good stuff, right? Like, we want self-driving cars and better medicine and all this other stuff, but also we don't want this, like, creepy surveillance economy thing. And what I'm going to talk about is a framework for boiling down that creepiness, understanding it, and trying to mitigate it, and get the insights that we want, but also not the super creepy stuff. And if you take away anything from this talk, this is what you should take away, as sort of like, well, this is one of the things, maybe, as the core of what is weird about this stuff. These are unwanted inferences. These are companies looking into this cloud of data that we carry around us and figuring out additional stuff that maybe we consider to be sensitive or private. So effectively, it's about not being creepy. So again, to sort of highlight the tension here, on the one hand, we have like these friendly things that we want to figure out, and on the other hand, we have maybe bad inferences. And you can actually pair them up really nicely, right? So if we want self-driving cars, maybe we have to collect a whole bunch of data about people driving and how that works. But on the other hand, once you do that and you catch people in this surveillance dragnet, maybe there's really weird correlations between like playing driving video games and your car insurance premiums. Same thing with medical research, right? If you participate in a medical study, a bunch of medical data is collected about you. If that gets linked to your health insurance company, they can jack up your rates. And that's a perverse incentive. You want to do a good thing for the rest of society and participate in these medical studies, maybe even for your own benefit. But if that's just going to get hoovered up by Aetna and used against you, that's not great. That's not what we want. We want to know on aggregate how satisfied people are with their devices, but also we don't want creepy ads following us around the internet the entire time. It's like, no, I Googled lawn chairs once, 5 years ago, and now you won't stop following me with the lawn furniture. Why? That just doesn't feel good. On the other hand, there's public health concerns where you want to understand the aggregate public health behavior of individuals. But also, you can go on Facebook and release sensitive information. Advertisers can target very sensitive health conditions using Facebook's AdWords. Is that something that we want to be possible? And finally, if you look at these energy grid problems, you now see that a lot of smart appliances are reporting their usage statistics and power usage to the companies that sold them. And then they're selling that information so they can tell when you're at home and when you're not at home, which is useful for marketing purposes. That ends up in data aggregators like, almost everything else. This is just Some of this is terrible and costs you a bunch of money, and some of this just feels creepy, and we don't want any of it. So what can we do about this? Here's a first attempt. Spoilers, it's not going to work, but it's really important why it doesn't work. This is Bill Weld. He used to be the governor of Massachusetts in like the 90s. And he said, you know what would be awesome? What if we took all of our state employees' medical records and we just like released them to the public to make medical research easier? So there's like a nice big public data set. Like we know that there's all sorts of reproducibility crises with medical research. Huge public data sets can help mitigate that. Awesome. And he said, all right, I know there's privacy concerns here, so what are we going to do? We're just going to delete the identifying information, right? We're going to scrub out your name, your social security number, your address. It'll be fine. And I kind of have to hand it to the guy. He was so confident that this was going to work that he included himself in the data set. There were no exceptions, right? It's like, this will be fine. You know, it'll be good for the public, so medical research gets better. And effectively, your personally identifying information is scrubbed out, so awesome. Let's do this all the time. So this is LaTanya Sweeney, and at the time, she was a grad student at MIT. Now she's like a professor at Harvard Public Health or something, somewhere at Harvard. And she had access to some voting rolls, which you can get for like $25, a phone book, and a newspaper, because it was the 90s. And she said, I don't know how private this actually is. Let's start running some fun queries on this database. So first, she used these publicly available sources of information to find Bill's zip code, and then queried the state medical employees' records. Okay, give me everything that shares Bill's zip code. That narrows down the data set. Next, you can get his birthday from, say, the newspaper, or for our birthdays are available everywhere now that like Facebook exists. That's a super public piece of information. She actually got it from voting rolls. That narrows down the data set some more. I'm sorry, these are supposed to be different colors. No. And then finally, using her eyeballs, she could find out that Bill Weld identified as a dude and further refine the data set. And the fun thing is that there's just one record here. It's Bill's. So this being the 90s, she mailed him his medical records in the post to make a point about how uniquely identifying these seemingly innocuous pieces of information can be. This is a pretty, okay, I don't want to call this an unsophisticated attack because it was the first one ever and it was awesome, but the power of current systems to perform these kinds of attacks by correlating seemingly disparate pieces of data is amazing and goes well beyond the technology here. But this is the conceptual core of these types of attacks. Okay. They're called linkage attacks, right? Because what happened, there were 2, maybe 3 databases, and sensitive information in one database, they tried to scrub out the identifiers, but by linking across databases, she was able to mail Bill Weld his private medical records. So what did we learn here? Scrubbing is not going to work, okay? So what now? What are we going to do to actually solve some privacy problems? We want to have our big data cake and also eat it. Let's take a step back and actually just look at what happens in these scenarios. Let's do a fun thought experiment. We take a whole bunch of data and we feed it into a thing made out of mathematics and wishes, and we hope desperately that it produces some kind of insight about the data set that we can then use to like make money or give people good drugs or something. Now, let's say that there's this guy, Mark Bunn, who's a fictional person that I made up, and we don't know if he's in the data set or not. Okay, this is a thought experiment. One possible world, Mark is in the data set. One possible world, no Mark. In the no Mark condition, we get one kind of insight. And in the actual Mark condition, we get a star of a very different sort of color. This is not private. This is not private with respect to Mark's record. The intuition for that is that including Mark in the data set had a significant impact on the outcome of the analysis. Okay? So this is the thought experiment that we want to use to think about privacy. Let's try a different condition. Notice that I have changed the colors of the stars. What that means is that including Mark or not including Mark isn't changing our insights so much that we're getting from this analysis. And that should be appealing from two perspectives. Perspective number one is this privacy perspective. If Mark participates in a medical study and his insurance company can't really tell the difference between if he participated or not, if they're a reasonable company, they're not going to jack up his premiums by like $800 or whatever dollars, right? Because the Mark condition and the non-Mark condition are indistinguishable. Good. On the other hand, should one person affect the outcome of a big data analysis that much? No. That sounds like overfitting. That sounds like a weird sensitivity of this Rube Goldberg machine in here. So privacy is useful for two reasons. Reason number one, we protect whether or not Mark is in the database. So based on his participation in a study, his health insurance can't go nuts. Reason number two, we sort of automatically prevent overfitting, because your analysis shouldn't depend, like when you're processing, say, hundreds of millions of records, on whether or not Mark is in your data. All right. Okay, so this is the definition of differential privacy, where I've introduced some sophisticated notation by naming X Mark Bunn, okay? We do our thought experiment, and we say, okay, we have two worlds. Mark's in the data, Mark's not in the data. We run our analysis, we get some output. It better be the case that the difference between these outputs is at most epsilon, which just means some tiny quantity that we don't care about. So what differential privacy actually is it's a property of this analysis. And what people in academia and also at Google, Uber, Apple, and the US Census Bureau have been doing is they've been taking standard statistical methodologies and replacing them with private versions that have this property where if you run this thought experiment, you don't know whether Mark participated in your survey or not. Okay. So differential privacy is a property of the analysis that we can use to enforce this thought experiment coming out the way we want it to. I'm actually going to skip this part. Okay, so here's a concrete example of how we could actually enforce differential privacy. Let's say that we've got a curator sitting on a whole bunch of data, perhaps sensitive medical records or sensitive marketing information, and we want to interact with an analyst, some kind of mad scientist, who's going to ask us questions about the data, and we want to answer them so they can do their science. Good. Now, marketing data can have sensitive attributes. This is Justin Bieber, if you don't know. And some people might not want us to know whether or not they're Justin Bieber fans. So let's suppose that the analyst first asks the curator, how many people are Bieber fans in the database? Okay? Get a count back. It's like 700. And then, how many people not named Mark Bunn are Bieber fans? Say we get back a count and it's like 699. Oh no. We know if Mark's a Bieber fan now, right? And this is a super reasonable model of interacting with data that someone owns, but you're allowed to query behind a database, right? So this is called a differencing attack, by the way, and it's why differential privacy is called differential privacy, because it protects against this type of attack and many others. What are we going to do to protect Mark's information? Well, we're going to change the interaction. We're going to say, okay, every time we answer a question from the scientist, let's like add a random number to it, between 1 and 10. That's all. That lightning bolt means random noise. So now, if how many people are Justin Bieber fans comes back as like 700, and then it comes back again with Mark's difference removed as like 695, Mark is safe. No one knows. This is a design pattern for how to put differential privacy into mechanisms. It's generally injected by very carefully screwing up the computation, just a little bit. So you take similar individuals and kind of smear them together in your analysis. So you can't tell the difference between was Mark in the data set or was Mark not in the data set. Okay. So Apple counts words to like make your keyboard work on your smartphone. Otherwise, it wouldn't be able to autocomplete stuff. And in particular, it wants to be able to autocomplete new common words like bay and bruh, perhaps. So how could Apple accomplish this? They could hoover up all the texts you send and just count the words in them. But maybe that's not great. Maybe you don't want Apple reading all of your texts all the time. So what they do instead is on your device, they take counts of the words that you use, they add a little bit of noise to them, and then they send it to a special server at Apple that aggregates the counts across a bunch of individuals. So what they end up with is only aggregated counts, nothing that they can link to you and nothing that's identifiable. So they look at like how common are these emojis used. This is what happens actually on your phone. So to detect common emojis, Apple is going to only give small random samples of your counts to their own servers. So they can't fingerprint you based on your emoji use. This may seem like a trivial example, but it's actually super easy to identify people by simple counts of their words. So if you were to say, provide anonymous feedback on some kind of survey that includes a written comment, if your word counts aren't privatized, you can easily be identified by that kind of information. So that's our sort of real-world application. Sorry, my phone seems to have, I blame Apple for. So thank you so much for listening. And I'd also like to thank Mark Bunn for teaching me a bunch of things about differential privacy and participating in Justin Bieber-related experiments. Here's some resources and links that you can take a look at. On Professor Sweeney's website, there's actually a wonderful tool where you can plug in your birthday, zip code, and gender, and you can see how easily that identifies you uniquely, which is pretty cool. And she has a bunch of other tools there, too, for doing differential privacy. Google also has a system that's actually open source for collecting privatized statistics from users. That's called Google Rapport. Apple's thing that I referenced is called Learning with Privacy at Scale. And the Harvard University Privacy Tools Project is a bunch of other pieces of software that that are open source that you can think about, like if you have access to a giant pile of health data, or if you want to do analytics on users' devices, maybe you want to start privatizing those things, look into these links. Thank you. Yeah, no, for sure.
It's kind of a common question, not common, but I noticed that when you were going over a couple things, I noticed that when you were going over kind of the pros and cons, that it seemed like it was structured as a zero-sum equation where it's either like somebody's winning or somebody's losing. And I also noticed that, and I'm not sure if this was intentional, but kind of completely avoiding the fact that in this day and age, data is valuable in and of itself, and furthermore, the accuracy of data is of utmost importance and value. So by having people who have data obfuscating it in some way or adding noise, as you say in your equation, by essence, what you're asking people to do is make their data less valuable. And so their cost there is a zero-sum game because it's zero-sum with the privacy of people's data that they're collecting. So with that kind of as a context, also with those pros and cons, something to keep in mind is the fact that if you didn't have, and this is a little bit of a devil's argument here, but if you didn't have all this collection of data, then the value proposition would be, would you pay $15, $20 to use Facebook this month?
You know, that's
it's kind of the counter argument to like why are people collecting all this data? Like data in itself is valuable, and data has been collected since commerce was created. People kept in mind like, oh wait, he's a client of mine, he's a customer of mine, so when I have more bread next month, I'm going to ask him if he wants to have a loaf of bread. And this is just really getting to a point where it's becoming a little bit scary because you no longer just have people who are talking about 100 different people's consuming habits within a certain spectrum, but you're talking about companies that are now talking over millions of people and all their consuming habits.
So there's three things that I want to look at there. So first you said I'm phrasing it like a zero-sum game. That's true, that's a simplification. A lot of the results in differential privacy are actually phrased as a curve, where you can trade off between privacy and utility. And the fact that we now have this thought experiment that's like well supported by mathematics in a similar way that cryptography is, means that we can have this conversation now. We can decide in regulations and in our interactions with companies how much utility do we want to trade for how much privacy. So like that's one part. It's absolutely a spectrum mathematically, which is quite interesting. The second part is I want to revisit something that I said quickly earlier. It's true that adding noise seems like a terrible idea, right? Like, wouldn't that just damage the accuracy of my data set? But one of the other things that adding noise does is it prevents what we call overfitting, which is part of the reproducibility crisis in science. You often see models that depend too much on individuals in the data, that are too ad hoc, that don't accurately predict individuals out of their sample, right? So there are ranges of the privacy parameter where you can kind of have your cake and eat it too. You can enforce, because the company also doesn't want to overfit, right? Because if they overfit, they make bad predictions for the future. I want to have my data hidden to some extent. For some problems, you can actually set the privacy parameter such that it only prevents overfitting and doesn't damage the accuracy of models, and it kind of smears out the individuals and gives us some sort of privacy guarantee. And finally, my third point is, now that we have this enormous amount of data following us around all the time, we need the tools to talk about that trade-off. Because I certainly wouldn't pay $20 for, I'm not on Facebook. I wouldn't pay any dollars for Facebook. I don't want to use it at all. But I probably would pay like a good deal more for Netflix than I do now. If we had some kind of accounting and a common language for talking about this, we could all make those decisions at like a governmental and a personal level. So yeah, this talk is very much about like sparking that conversation and deciding what to do going forward with the incredible amount of inferences that we can make now. Yeah, thank you.
Yeah, and just a little bit further on with your example of like Netflix, for instance, and it was very good. I can't remember the specifics, but similar to the Sweeney episode, Netflix kind of coded and said, "Here's all this data. They have like $100,000 bounty to predict the next 5 movies that people will watch." And one of the people came back and said, "I can identify like 5 people in the city exactly who they are, just based off of what they watched on Netflix and the data that they released." Even after they went through a couple rounds of anonymizing the data, et cetera, et cetera. But it also brings up the point that a lot of these products only exist because they have very accurate, detailed data of your behavior, and they know the things that you are interested in. So there's a lot of functionality that we don't necessarily think about in modern day products that are completely based off of the fact that they are able to then actively basically collecting our data, turning around, running through the algorithms, and giving it back in.
I do want to note that the Netflix release was actually one of the things that prompted work on differential privacy and creating this thought experiment. The Netflix release was pre-differential privacy, so it was actually one of the motivations for putting this framework for thinking about privacy together, because they did use what was at the time like sort of, I don't know, best known scrubbers and anonymization technology, but it just did not hold up. Whereas DP definitions are much, much more difficult to attack. Like if you use differential privacy properly, you could have run the Netflix competition with about the same amount of utility, like a small impact in utility, and robustness against these de-anonymization attacks. So going forward, people are trying to push this definition out there and get it used in products and services, because in some situations, you can have your cake and eat it too. Not all, obviously. But those situations, we at least have the framework where we can talk about the trade-off, right? We can decide how much does privacy matter versus how much does utility in this specific area matter, and go from there.
So then the question is going to reply on maybe a quick comment. I think part of what the discussion, that Marco's kind of laid out, the sort of the shift in the sort of dialogue about these things is, really people should have agency over their own privacy. So I think the argument that some tech companies have made is like, you can't have any privacy because our services can't exist without.
Oh, no. I personally, as I said before, I was kind of playing devil's advocate a little here, like there's a counterpoint. And maybe I'll open this up. I think that there's bigger issues with encryption and security and making sure that when you are sharing your data, I'm sharing my data with you and I'm making that conscious decision. And the frameworks where you can allow me to make a conscious decision, share my data with you, and not having it intercepted or interpreted by somebody else. I think that as you open up your talk, it wasn't the fact that Equifax has information on us, or that Chase has information on us. I used to work for Harvard Card. We knew everything that people were buying because they were using their credit cards or because we were the merchant bank. So we knew all these transactions. That wasn't an issue. It was only an issue if somebody hacked us, because we could be corporately responsible with that data because we don't want it. So Chase doesn't want it. So Equifax doesn't want it. So it's more about increasing the cost from a public point of view, and by that I mean basically the public shaming people do crappy things like don't update their software, or companies that are collecting ridiculously personal information, but they're startups, and so their budget for security is $5 grand a month or something, but they're putting $150 grand towards marketing. Those kind of things, those are the bigger aspects. I believe the privacy is about making sure that when you are consciously sharing your information, first of all, it has to be a conscious, explicit decision, such as, hey, this site wants to know where you are and what page you're going to. The last site we visited wants to know if you landed on this page, those kind of things.
What's interesting about that is that there's this gigantic engine on the internet that I'm sure that all of you are aware of to some extent, that links your behavior across, ad networks do this, right? That link your behavior across websites. They interact with the data brokers that I was talking about, and security is obviously extremely important, right? Like when we're actually sharing data with someone who we know who they are, they have a trusted certificate that we know it's actually this company. You can only enforce point-to-point privacy so well when you've also got a surveillance dragnet running in the background, basically. So these are two separate types of harms, right? Like, if I show up on a website and they say that they need certain types of information from me, do we extend that to their ad networks, have also correlated a bunch of inferences about me that they're going to tell the owner of the website, or do we just restrict it to the information that they need to do their business, right? So this is where I think the discussion needs to include both privacy and security issues. The reason that my talk now was about privacy is because I think that these sort of unwanted inference discussions are just less present, right? So that's sort of point number one. And then point number two is many startups, I think, could do what they want to do. They could do their marketing, Like, Apple makes its predictive keyboard by throwing away most of what you type and sending clever aggregated statistics over to Apple. So one great way to cut down on companies having a bunch of private information about you is to just not collect that information in the first place. It's a liability. It's like a toxic waste dump at the company where if anybody cracks in and gets it, that's terrible, and you're dragged through the media and like through talks by jerks like me for months afterwards. So many of these sorts of simple and even not so simple analytics tasks can be done with privacy guarantees, so you never actually have that information to worry about. So privacy can very much impact security, because if you're in sort of that sweet spot where you can have utility and privacy simultaneously, you never need to collect that awesome treasure trove of toxic data. You just don't get it to begin with. So you don't need to defend it. Sort of like security jujitsu.
Do you think there's some similarities between, and I'll just compare modern day to if you were around, like mid-90s and the evolution of both the regulation side of it and also the technology side of like PCI compliance? It used to be like Wild West. If you wanted to sell something on the internet, and I was involved with it, it was like, hey, send me your credit card, and I'll have that credit card, and literally it's on like a flat unencrypted file on a server somewhere, and then we would download it every night, and you punch it out and charge me. Like there was a time where that's how websites worked.
Well, there were
That-
all businesses. There's several like people. Yeah, because look, you're part of the but you're going down to you're right next to the gas station.
Exactly. But nowadays, most modern, we'll just say like we can only work with the smart people who are going to somehow be in society, right?
That's exactly what the privacy community, the differential privacy community, is shooting for. Because like you said, you know, back in the early 90s, it was like, okay, you're gonna give your credit card number to strangers on the internet? That seems suspicious. Now, if I said, you want to upload your private medical records to like this one server, a bunch of people are doing it. It's gonna help discover drugs? You would think I'm crazy, don't do that. But using the same types of mathematical guarantees that guarantee the cryptography that underlies those PCI standards, we can also centralize and guarantee privacy. So like what this community is really shooting for is a reality where you think almost nothing of certain kinds of participation in like a giant data collecting and analysis apparatus that you can opt into and that you understand the properties of via like thought experiments and explainers. So yeah, I forgot to draw the parallel to the 90s cryptography. Thank you.
This thing of the differential privacy community aim for this is good. There's also like a counterpoint for companies that really want the data and profit with that data, right? Data that is not private, but they actually want to store and sell it on legal markets because it's legal, right? Facebook, Facebook sells your data.
Yeah.
And that's what even regulations like the GDPR.
Yeah, the GDPR is mostly written from a security and like a pre-differential privacy standpoint. It does give you rights to control certain parts of your data and rights to like figure out what it is, get it deleted from servers, but very importantly, it doesn't control what they can guess about you, which is what.
It's not very American to say that we need regulation, but I mean, this makes this regulation, right? Because,
Yes.
I mean, the capitalists want to just profit from it, and if they have to pay they will do it, right?
Absolutely. And differential privacy is about giving us the language to write those regulations and have them actually do what we want. And until then, until we get laws that actually protect our privacy, individual companies that don't want to have like a toxic cesspool of God knows what analytics about their customers hanging around waiting for a breach can sort of preemptively deploy decent guesses at, okay, what could we hope for in a future regulatory framework? But much like with the PCI example, the ultimate goal is regulations that use this framework as the language to really capture and talk about these types of privacy problems. Yeah. So, no, that's not.
There's regulation, but also the fact that companies just got sued into the ground because they were kind of working just completely net. And so it became, as with everything in capitalism, it becomes a risk. You have to have like risk benefit.
And you have like
And
a Apple.
right now, you frankly don't really have that much risk. I mean, even in the worst case scenario, Cambridge Analytica style or what have you. Okay, well, the people who are involved in Cambridge Analytica, do you think that they're all like poor and impoverished and
They actually started a new company, and
the risk is basically like, hey, if we can make like 300 million and then sure the company gets sued out of existence. Okay, fine, then we'll just start something else up.
yeah, they did.
Until you get to the point where, like PCI compliance, where you can find somebody actually criminally negligent if they
I actually forget the name.
secure data, and they're criminally negligent to fraud. That was really the tipping point. And so now at this point, as people know, like for PCI data, it's toxic. People don't want. Companies will spend hundreds of thousands of dollars a year to just not touch credit card data. And they all pay swipe. They deal with all pay PayPal. They can deal with the risk.
So one possible world that we could move towards with this technology is a Stripe-like company or a Stripe-like government agency that does take the risk of actually holding on to private data and society-wide controls over who can query that and how. Like that's if we go back and look at like the curator scenario, that's one situation we could be in, where like all of these companies that want their marketing to work and stuff, they can just ask queries to the data set that are noised a little bit so they can still get good insights from the data that definitely don't overfit, and they can't personally identify weird, creepy stuff about people. So that's really like the take-home point of this talk, is that differential privacy is a framework for sort of taking this vague unease that we have about data collection and at least putting a name on it, thinking about some version of that and saying, okay, let's work with this concept, see what guarantees we can have, and use it to start. Companies that care about privacy and want to make that part of their marketing are using this technology, and use it to start the conversation about what kinds of regulations we want to have as a society, so that it's not like the wild credit card west anymore out on the internet. You actually have some awareness and some control over what companies are guessing about you based on like your data cloud. So no, it's far from finished, and like a lot of my research is sort of taking some of this stuff out of academia and research papers and shoving it into analytics in the actual world. Like I work on private machine learning algorithms, where you can train a model on a bunch of really sensitive medical data, which is often a thing here, and actually release that model to the public so anyone can use it to make predictions. If you didn't train that model with privacy guarantees, people can look at your model and often extract random records of individuals that were like important to the data set, just like their record wholesale, because the model was smart enough to memorize a bunch of people close to like the decision boundary. And that's really not good for these types of studies. So yeah, so that's another application that we could see going forward. Yeah, if we want to wrap.
I'll make one short comment. I really do think Apple is a great example of what companies should be doing, can do. I mean, Apple already makes a lot of money, and they've chosen to really invest in privacy. They've kind of tripled down on it, and it's not only minimizes their risk in terms of having large sets of data that can be exploited, but it's in their benefit because it's good for people. Everyone deserves privacy. So you can tell I'm a fan of Apple. I know a lot about them. These days at Apple, if you're on a product team, you can't ship stuff without like a really serious privacy story. Like, here's how the keyboard works. This is what we're going to do to make it private. And then also, interestingly, in October, with the new release of iOS 13 and the next version of macOS, Apple's going to be offering a sign-in service for apps. So you know how if you have an app, you can sign with your Facebook account or your Twitter account. Now you'll be able to sign in with your Apple account. And when you do that, say you're building an app, right? And you're looking to sign in with this Apple service. When a person signs in, all Apple tells you is, yes, a human has signed into your service.
Here's a long random number.
By default, you don't know their name or their email, and it's up to them to give you that information option. So it's really just.
But just really quickly, Apple's not a data company.
No, but they are in a really great sort of position.
They're in a great position to affect the client side, but it's really easy to say privacy is number one for us when we don't base how much
they can
money
affect the
we make.
market, and they can start a trend. They use those features as a differentiation. So, with other companies, right? All this is saying about
Yeah,
Google
they
and
would probably force Google, Microsoft to be more into privacy.
Yeah, but once you go from Apple, who quite frankly is not a data company, you go into an Amazon, you go into Google, those types of companies, when 90% of their value is either their vehicle for collecting data or their stored up amount of data that they have on people, it's a lot harder to make those arguments at a board meeting of saying, hey, we need to focus on privacy and cut back on how much data we're collecting.
Yeah, I mean, your argument is sort of like the status quo is, and therefore it shall be.
I guess I was just pointing out, sort of like, it's a shining example of a company that is taking a privacy first approach.
Yeah.
But privacy is easy if you're not in the business of
You mentioned that imagine someone in a business for saying that, I think because Apple did it, I can hear in a Google meeting people say, hey, what can we do about privacy? Let's start this kind of conversation.
It's the beginnings.
And I would say too that it's a never-ending changing ecosystem, right? Like even Apple this week had the privacy concerns with the watch and listening and when it shouldn't be. So it's ever evolving, and especially when market forces start to play on these big data companies, and there will always be a monetary incentive to get at more personal data. So it's always going to forever be changing and evolving.
There's no more. Thank you so much.
Alright, lightning talks. Did anyone put in a lightning talk sometime today? We'll put it on, right? I checked this morning, I did not have any left. So in the future, you are absolutely welcome to do a lightning talk here at SCP, especially if you